Since we've talked about how to factor quadratics, we're now going to move into how to find solutions of quadratics. But first, we want to actually talk about what solutions are. Solutions are answers to our question. They are x's, often points of intersection. And they can be represented by graphs, and tables. In Math 2, we're going to look at only two, but I did want to put, you can find solutions using three different methods. The first one will be factoring. To find a solution when you factor, it's the same process when you use factoring. However, now you must solve for x. Okay, so for example, if I have x squared minus x minus 6, and I want to factor this, it could be x minus 3 and then x plus 2 would be the factors, because x times x is x squared. Or I'll just do the box method really quick. And all I'm doing here is just going back and verifying and making sure that my factors were correct. So I have x, negative 3, x, positive 2, x squared minus 3x, 2x, negative 6, and again, combine like terms. Then whatever's inside the box you add. So I have x squared, negative 3 plus 2 is minus 1, and then minus 6. So this is what I originally had, so this checks out. Now, where I said all you do is solve for x, you take your factors and you set each one of them equal to 0. So I have x minus 3, and set it equal to 0, solve for x. So I add 3 to both sides, x equals 3, and I have x plus 2, set it equal to 0, get x by itself. Now, and also you always want to have equations and set your equations equal to 0 if you're given an expression, right? Because a root 0 or solution is where the graph crosses the x-axis, which has a y value of 0. Remember, when we have functions, so like f of x equals x squared minus x minus 6, f of x you can really just call y. So y equals. Now, the reason I don't like to factor personally is because we've already seen a handful of different methods, such as GCF, slide divide bottoms up, completing the square. So there's 3 different ways, and depending on the problem, you may or may not be able to factor. So you're going to have to practice and figure out which of those you can use. Because of that, I avoid factoring and I use the last 2. Okay, the last 2 that I use, I always start off with this one. And then if this one over here on the right doesn't work, I then go over here to the left. Reason being is because the one on the right is the easiest, and the one on the left is, well, requires a little bit more work. So the one on the right is actually systems of equations. You may remember this from Math 1. You did a lot of this by hand. The state of North Carolina said, congratulations, we know you know how to do this stuff by hand now. That's why you're in Math 2. And because you've proved to them that you can do it by hand, they've been nice enough to let you use a graphing calculator for the entire Math 2 exam. Because of that, systems now become very, very easy. Okay? Systems can be used to find any real solution. In order to find, or in order to do systems of equations, first thing we need to do is get two expressions. Whatever is on the left side of the equal sign goes into Desmos as a y equals. And whatever's on the right side of the equal sign goes into a Desmos and a y equals as well. The answer, right, we just talked about solution, is your x value where the graphs intersect. And that's all there is to solving systems now in Math 2. So I'm going to go to page 22. I'm actually going to pull up Desmos. And we're going to look at it. So first thing I want to do is set up two expressions. So I'm going to go y equals and I'm going to do another y equals. Whatever's on the left side of the equal sign goes in a y equals, and whatever's on the right side also goes in a y equals. So x squared plus x minus 2. I get to an equal sign, so I stop. And then I start my new one. So negative x plus 1. So come to Desmos, y equals x squared plus x minus 1. Whoops, minus 2. Make sure you type your equations in correctly. Once you type your first y equals, you're going to stop, and then you'll start a new one. So y equals negative x plus 1. And your answer is where your graphs intersect. So I'm going to zoom in, and I can see that point right there. Now remember, Desmos will throw up key features or key points of graphs if your cursor is on an equation. So I have 1, 2, 3, 4, 5 points. And again, the only ones I'm interested in when I'm solving is the points where my graphs intersect. So that point I want, and that point I want. And again, you can take the entire point. So I would say at points negative 3, 4 and 1, 0. Or you could say the set of x's. And remember, the squiggly line means set. So negative 3, 1. Either one of these is acceptable. So we'll go do another one. I'll just do the one below it. So again, whatever's on the left, I get to my equal sign, so I'm going to stop. And then whatever's on the right, all of that goes into a y equals. So y equals 2. I'm going to stop. Now I'm going to start a new y equals. X squared plus 4x plus 7. Whoops. So I'm going to zoom in, and now I can see that the blue graph and the red graph don't ever touch. So I would say there's no real solution, or no intersection. So again, if they don't intersect, there's no real solutions. That doesn't mean there's not a solution, it's just not any real ones. Okay, and we'll talk about in the next video on what we do when the graphs don't intersect. So we'll do one more. And sometimes you'll find questions that ask about how many real solutions. And the quickest way to do that, again, is to just type them in, see how many times your graphs intersect. I'll probably get the question, do I need to put y equals? I absolutely would. That way Desmos knows you are wanting to type an equation. And also, if I have just a number, right? If I have 2, it's not going to give me a graph. But watch what happens when I put y equals 2. So it gives me a line. So make sure you're always putting y equals negative 12x plus 36. Again, you may need to zoom out a little bit so you can see where your graphs intersect. Get your cursor back on your equation. Gives me that point. So negative 9, and that's not where they intersect. 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 But right there. So at negative 9 and 8. So x equals negative 9 and 8. So again, that is how you solve systems of equations by graphing. I'm just going to highlight this box right here so we can come back to it.